fantastic talk. Now we're having a talk from Michael Dubois, and Michael's going to be talking about ArduPilot Lua scripting, which is one of the most exciting new features that's coming up in... over to Michael.
All right, so Lua scripting, just really quickly, we've talked a lot about this last year, so just to repeat the first slide really quickly. It's embedded scripting language. We're going to run it on the ArduPilot and let's do scripts on the ArduPilot. Has fairly easy binding to C and C++, which made my life sane and manageable. Has a pretty small footprint, so the current state of what we have running right now with GCC 03 is taking up about 300K of flash. And that's just going to keep increasing as we add more bindings, but it is fitting into the existing boards quite nicely. It's already popular inside the OpenTX community. Apparently inside this room, it's not popular because it's not Python. However, it's not Python, so I care about it. And that was the key point. So what's happened since last year? So last year I got...
Sorry, just for me, why is Lua good?
Because it's not Python.
No. Do you need more excuses? One sentence. Python is good. What are you talking about?
It's a dynamic scripting language. It has a very low barrier to entry. It's very easy to learn it. And it lets you add your own scripts to the ArduPilot easily without having to recompile the code. And it puts you into a sandboxed and safe environment. So if you dereference a null pointer in the scripting engine catches that and doesn't panic. Dereference a null pointer on the aircraft and we lock up and you fall from the sky.
Might be worth contrasting scripting within the ArduPilot versus on a companion computer versus on ground station.
Yeah, so I had a bunch of slides on that and I dropped it. I was hoping we were somewhat there. But the main thing is with companion computer, I'm dependent on the telemetry link from the aircraft. So I need that MAVLink data. MAVLink is a lossy protocol. Also running on the companion computer, you have the extra delay there. You have more external hardware you need. So scripting lets you run something that's small onboard the flight controller without more hardware. And then we also run into the problem with MAVLink and your companion computer that you're limited to the MAVLink interface. So if we don't give you a message that has the information you want, you don't get access to it. And then we can only publish information so quickly. So if you need the most recent version of your location, you're stuck with however recently we managed to pump it out with the rest of the telemetry to you. And that could be very stale.
So do we want to like do something like we can run the same Lua script on the companion computers as well, so there can be an ecosystem developed on companion computers which can portable to...
You'd have to emulate the entire ArduPilot internal API. So like right now in scripting, you can ask AHARS for position. So if you ran that same script on your companion computer, you need to have a way to ask AHARS for position.
So is there a way to like basically create findings around MAVLink to do that? Is that something that
you could chase it. You can. Some of the things would be pretty easy to make bindings like that for. But from my perspective, a lot of the utility in scripting is accessing things I can't get over MAVLink. So you just wouldn't be able to see those functions. So it really depends on what your script wants or needs to do.
Surely you could script that and then send it back over to it, couldn't you?
We are going to talk about MAVLink stuff, and we'll let you pump some data out of port. So you could actually address your MAVLink emulator that way, but then you're still depending on stuff on the ArduPilot. So since last year, I got nerd sniped into doing this by Tridge, because Tridge, somebody just has to prove that this works. And I went, well, this is really easy to do in CITL. It's like, no, it's not. I'm like, I guarantee this can be done by the end of the dev call, which I did it, and then this kind of just scope crept on me.
You were qualified to continue working.
Really not. So the initial support isn't master, so you can start to play with this. Some of the stuff we'll be demoing today is still in a branch that I need to PR within the next week or so, hopefully. But there's a number of small little things to clean up. But this is something you can start to actually use now. So scripts can currently be run in either CITL or Chibios. Again, within the next couple weeks, I'm going to add Linux support. And maybe if I find somebody with a Linux board here, I'll get that going. Because if we already have CITL support, then Linux support is basically just copy the same functions over. And it runs on Chibios to the point where we were doing demos with the rover yesterday with kind of a very silly script, but it is actually running and working. So scripts run in isolated sandbox. So one of the problems last year with the kind of demos and where we were is that it was just running inside the main ArduPilot memory. So now scripts are inside their own heap that's dedicated to them, and they're not allowed to reach outside of that. And I'm going to go into a bit more detail about how that actually worked out. And you can run multiple scripts at once. So you can stick multiple scripts onto your SD card, and they will all run concurrently. Well, not truly concurrently, but it's task switching. So you can have multiple tasks going. And again, we'll go through a lot more details on how that actually works. And the other side effect is I now get blamed as the future person who's justifying all this hardware that has more memory and processing power. Used to be Paul's role, and now it's my role, apparently. So talking about scheduling. Scripting itself is run in its own thread. It is the bottommost priority on the system. So if an AP logger wants to log data, that gets priority. If the flight controller wants to talk to its I2C bus, that has absolute priority. So scripting is meant to be such that if it crashes, your vehicle should still be able to fly safely and you shouldn't ever notice anything. The downside to that is from a script's perspective, you aren't guaranteed to run anytime soon. So if the flight controller really needs to work on, flying the vehicle, that's too bad for your script. So your script needs to be limited to add-on features that aren't flight or safety critical. You can still use it to create, extended or more complicated fail-safe actions, but you should still be relying on the core internal C code for your fail-safes.
So you can be out by a bigger processor.
Yes, which is what the hardware people love to hear is the answer.
No, we don't.
So scripts are currently loaded at startup. So any script that's inside the SD card inside the scripts folder will automatically be loaded, compiled, and then scheduled for running. If you run out of memory trying to compile a script, that script won't be loaded. We'll ditch it and we'll move on to the next one. We'll need to improve the reporting on how scripts are running in the future, but for now we've stuck with just getting them going and sending status text messages.
Probably a pre-arm for all your scripts have loaded. Pre-arm check.
Yes and no. So interestingly, you want your scripts to load, but some of the scripts don't have to keep themselves running. So you can actually have very useful scripts that are fire once, so they check that the vehicle is appropriately configured. So for example, you can have a script that sits there and says, I expect all these parameters to be set this way. Did anybody muck with them by accident? And yell at you if that's not. And if it is good, then it can stop and remove itself, in which case you get all the memory and processing time back. So some of the reporting on this stuff needs to be figured out better, but I've deferred that until we had stuff running, so we actually knew what we wanted to report instead of inventing messages first. So scripts are run. We said we can have multiple at once. And what this means, though, is you have to guarantee that a script doesn't take too long and starve all the other scripts. So a script says, I have this function I want to run, and then it has to complete that within the number of virtual machine instructions. We'll try and find a better name for that so users don't have to care what a virtual machine instruction is in the future. And we might actually end up wrapping that into a time value instead. But because you're the lowest priority in the system, time values are really hard to guarantee because we don't get enough support from the RTOS yet. Because we need to know if our task got unloaded to somebody else, and we don't have good support there.
We could fairly easily have a function that says the amount of time that this task is used.
And that would be nice in general, I think, for debugging performance. So a script is given that amount of time. If it exceeds that time, the script is killed, and it's removed from future execution. So a script provides a function that runs as its update function. The update function itself can return and say, hey, either run myself or another script again, and run it this far from now. So that lets you task your scripts into small chunks that run repeatedly, which is usually what you end up wanting. It's normally what you end up doing on the flight controller anyway. You have your navigation controller, which runs the same update function on a fixed time step. So this is doing the same thing with your script, where you define the time step. And I'm hoping that's not going to be too challenging for users. This is the same way something like OpenTX works, is it just steps into that entry point. The main thing is we've let you change what your entry point is, so you can dynamically change where you want to run. So if you had a script that was a state machine, for example, you can say just run this function next, and that's your swapping states. It's just changing what's the task that's scheduled. So as I said, the script itself is responsible for returning a time to run itself again in a function handle. And this works out pretty well. We'll look at an actual example of what this looks like in a script. But this is just giving you the flexibility to control what you want to see executed. And then finally, again, only one script can run at once. So the main thing is to let multiple Lua environments run at the same time, we would need multiple heaps, and that starts fragmenting our memory really badly. So everything's running inside the same overall memory pool, but each task has its own sandbox. Which moves us very nicely into scripting memory management. So we're depending on the HAL to provide us a pool of memory to work with. So we ask the HAL on startup, give me a fixed pool of this much memory, and then we're going to ask the HAL for realloc, and we just realloc inside of that memory continuously. So Lua just wraps all those allocations, and Lua provides the garbage collection, which again just goes down to realloc in the end. The user can change how much heap is allocated to scripting. So we have a default value, I think, at the moment of 32K. But if you have a lot of memory on your board, you can increase that. Again, I think we're going to want to make this dynamic in the future, but the problem is we have a number of things that dynamically try and say, how much buffer can I grab? And if you put all of those together, only one of them gets to grab all the buffer and everybody else is starved. But the scripts we've been running so far fit pretty nicely in 32K. I do want to note that if you're testing your script in CIDL, which has the same 32K default, just because you ran out of memory in CIDL doesn't mean you run out of memory elsewhere, just because CIDL runs in 64-bit. So all your integers and pointers are much larger. So the same script demo we were running yesterday doesn't run in 32K in CIDL, but runs happily in 32K on real hardware.
Is there reporting of how much memory is actually used?
You can ask Lua for it. I don't have that printed out to you. Right now I do print stats on this script run consumed this much memory. So every time we run an update, we use this much. But we can easily ask Lua for it. It does require walking the table, though, which is a bit of a slow function, which is why we're not doing it all the time. And I guess I brought these two on the same one, but each script provides its own global table. So this is where your sandbox comes from. Lua, everything defers to tables. So your table is what you can access. So each script can't interfere with the other script. So if you write to a variable foo, and this other script writes to variable foo, they're writing to different foos, even though they both think they're global variables. And the other one is really for me with the generator, but scripting is meant to never retain a reference into core ArduPilot memory. So if you refer to a location structure in ArduPilot, we always allocate something onto the Lua heap, and we copy everything over. So you're not allowed to retain a reference to something flight critical where you could then try and modify it. Because I'm very sure that if I otherwise change that, I could retain a location reference onto the AHAR's position, and I could modify it from scripting. So scripting is never allowed to have references into the core memory. So the last one, and this is really what's not shown up in master yet. Everything else I've described till now is in master. This is the generator for bindings. So for scripting to be useful, we need to be able to access all of our interesting C and C++ functions internally. So for that purpose, there's a generator that will create the bindings. Should really kill Skype, apparently. Or you guys could, pay attention. So there's a generator for it. So this is just, I played around with a couple versions. I did a closure one originally, but I decided everybody would throw hissy fits if we tried to propose something that used Lisp as a generator. Let's move that silly Skype window. So the generator is able to access complex items. So we're going to call stuff like user data objects or vector3fs a more complex item rather than just a primitive value of an int or a float. It also is able to support access to singleton objects in ArduPilot, so stuff like AHARs and GPS. So I swear there were more slides there, but we've lost them, so that's fine. So this is an example of the current syntax in the generator. So if we look at this, you can say, hey, we're going to need to include this file, which describes location. Otherwise, when you try and compile your C++ code, it won't actually work. And then user data is the Lua term for an object. So user data are going to be things like location or vector3f. So we're going to have a user data type location. We're going to access a field on that. That field is going to be called latitude. The field type is int32t. Read write. So you can specify independently if this is a read-only field or if you want to be able to just write to it instead of reading it. For fields, we almost always want read write, but I do let you have the flexibility. And then I'm a bit of a paranoid person, it turns out. So I'm requiring you to provide a range to all functions you call as the acceptable range for this value. So if you're trying to access a latitude, it has to be within this range, which is the valid latitudes on Earth. So if you try and call this with something out of range, the scripting generator will actually throw an error and say, hey.
Or read as well.
Read, we assume whatever ArduPilot gives us is valid. So we're not sanity checking there. But if you try and write to it with an out of range value, then we throw an error. We could bring that back to the read side, but we don't normally do the internal check, so I've left it off for now. Things like Booleans, obviously, there's no sanity checking to be done on Booleans if they're in or out of range. So this brings out basically everything on the location structure you normally want. But then we get down to these, which are methods. So this is when you can start to work on top of it. So Peter changes recently, locations are always classes. So you can call getDistance on a location object and pass it another location. So at the moment, getDistance is the function we want to call. Float is the return type. So that's what we'll get back. And then location is the type of the first argument we expect. Now, Lua is a dynamic language, but it's worth noting we do have type checking. So if we say this is supposed to be called with a location structure and you call it with vector 3f, we do catch that and throw an error at you. So there is some level of protection for invalid or out of range inputs. The syntax on this gets a bit messy though, because while you can't do sanity checking for location, as long as it's not nil, which we always enforce that check, there's nothing else for us to do. On fields that you're passing into it, I'm still enforcing the range checking, which is making the syntax on this really bad. So one of the next future steps, I think, is we're going to break this such that this can be multiple lines, where each argument can be its own line if you wanted to, which would give this a lot more readability and let you stick a comment on the end of it that says, hey, this is this argument. But functionally, it works as presented.
So can we have for user data type inherently has the range defined, so we can get a user data float and convert it into degrees and have the range set there?
So you want to be able to tag it that, hey, this is supposed to be degrees elsewhere. It's not in there now, obviously, but yeah, that wouldn't be too hard to say this is a predefined range check and pull that in. We could do that. Then the only one that really stands out here is singleton. So things like AHARs are singletons, so we're not going to access them the same way. We have to know how to find them off the stack. But otherwise, the method syntax is identical. So questions on this before we kind of go on? Yep.
Pointers, arguments.
Exactly. Those are the open question.
Const arguments versus const reference versus.
So if you return anything to us, so something like get home returns a location,
yep.
I will always make a copy of it. If you return a reference to something, I'm going to make a copy every time. Currently, it's also making the assumption that if you're calling something, it's going to take a reference. Now, we're going to need to add syntax to allow you to pass pointers around. A quick audit of the code base showed that passing pointers was the least common thing, which is why I said the default is references, unless it's a primitive type. We're still going to need to support references on stuff like floats, because things like the EKF, get your variance call, depends heavily on those.
But some of them don't take a reference or a pointer, they take a copy of a structure. How does it work out that syntax itself, or?
Either it does, or I haven't hit the case yet where I've needed to fix it. And that's how a lot of this has been handled. But yeah, the pointers is one of the open things that needs to be fixed, and I need to add syntax for that.
Yeah.
So if that's our input, this is the brief output. This is just the loiter or cross-track. And this is C++ code, or C code in this case, really. So we're past the Lua state object and everything. That's how Lua works internally, is you always pass around a pointer to your Lua state object. So we call this check function. We define the check function internally, so we always generate that for you. But the check function just says, does this thing on the stack? So Lua works on the call stack. So is the first item on the stack, is it a location? If it's not a location, an error is thrown, and we just don't continue down this function, because Lua uses jump, so return never comes back to us. So then we ask Lua how many things are on the stack. So this is how many arguments have we been called with. If it's one argument, we know that you're just trying to ask us what the value is. If it's two arguments, that's you passing a copy of ourselves. So you're going to pass in, you're trying to set it. And otherwise it's something we don't care about and it's an error and we throw an exception at you. So then push integer is just saying, hey, let's actually dereference the user data object of the location we found, and just pushes it back onto the stack. Return 1 to tell Lua, hey, we have one value for you to look at. For the most part, I don't want people to have to understand how the Lua C API works. If you're willing to understand how it works, we are going to have probably some manual bindings. But the generator is trying to save you from having to write this every time you want to access just a Boolean field. Everybody happy with that? So current generator issues. And these are things where some of these I'm going to come back to because I have suggestions. But we're really inconsistent on our singletons right now. Sometimes we do references, sometimes we do pointers. I just don't want to deal with both of them. So I have a proposal where we just say calling get singleton always returns the pointer to us, and I do null checking. If you want to use the AP namespace, that can return the reference. But within, if you call like AP GPS get singleton, that should always return a pointer, not a reference.
Yep.
And that just lets me not have to have special syntax in the binding description. Because every time I have to do more special syntax, it's frustrating. More primitive types. So I've added primitive types so far for things that are interesting. So I still need to add, int 8 and int 16. The open question on that comes with things like uint32. On a 32-bit platform, Lua only has signed integers. So we have to decide what we want to do there. I don't have a strong opinion yet, but we will need to find a real solution. So arguments by pointer. And then static functions. We've mostly coalesced now to using singletons for everything, but we have things that are all static functions. So stuff like serve channel and RC channel, almost everything on those acts with static functions. So I need to add a static variant or something. Unless we decide to add the singleton support to those, in which case we call it singleton 1, but probably don't want to do that. And then add lots more functions.
I mean, they can be static functions, still access them by the singleton. It's harmless.
Yeah. So.
Except that it's low performance, but it would be.
We're already in the low performance realm. We're a script.
Yeah.
And then finally, the generator uses a make file. So I'm going to hide as everybody throws stuff at me, but I used make instead of WAF because WAF is confusing.
So I get converted.
Yes. But it is the generator itself. The generator itself is running off of C code. So it's a single C file at the moment instead of being Lisp. Lots and lots of useless stir talk. So we're going to move into kind of a description of Lua itself for people. If this gets too boring, yell at me and we can skip over it. But if you want to learn in Lua, number one recommendation is this book, Programming in Lua. It's relatively cheap, but it's also written by the author of Lua. The first version of it is available online. Fourth edition is mostly relevant because we're using Lua 5.3, which adds support for integers. So that doesn't show up till the earlier one, till the fourth edition. That being said, pretty much everything else is going to stay consistent for you. If you're trying to write the C API, the first and the fourth version will cause you problems, but otherwise, it's no big changes. And the final note is it's actually easy. It's very easy to pick up Lua. If you already know how to program at all, you should be able to pick up Lua competently within a day. There's not a lot of stuff going on with it, and then for new users, it's a nice and fairly friendly way to get started. So, basics. Again, it's not Python. This is exciting. It's a dynamic language, so you don't have a type checker in advance saying you've called this with the wrong type. You'll hit that at runtime. And this is a bit frustrating because I actually really like static languages, so I don't know why I'm the person doing dynamic language bindings, because I love the compiler assist, but you will have to be aware of this when you're writing your script. We do print out the compiler error messages for you, so you do get to go back and look at them. But it does mean your testing needs to be a lot more thorough, because basic errors can slip through when you write the file, and you won't see them until you actually hit them at runtime. But again, it runs in CIDL, so test your scripts in CIDL.
What is another option in terms of microcontroller?
Scripting languages?
Yeah, well, but it's static type.
I don't know of many static scripting languages, because that tends to, they're very orthogonal to each other.
Well, okay, but the problem space,
That's not a scripting language.
the problem space is being able to take, the pre-built ArduPilot, but you've been able to add your own functionality without, forking that problem space.
I don't know off the top of my head. I'm sure there are some, but.
Should we explain why we didn't do Python? Because I could address that if you like.
Yeah, go ahead.
Yeah, so
but it still has the same problem, for the record.
We did consider MicroPython, which was a serious possibility, and because there is Python for microcontrollers. One of the biggest reasons we didn't do it is the flash footprint. You can run it on the STM32s that we use, but it uses, to be useful, it uses about 256K of flash. That's just very basic, and then if you want more features, it's considerably more, plus a lot of RAM. It would use probably 4 or 5 times as much RAM as Lua. It would use several times as much flash. And even with the latest generation microcontrollers like the H7, that we'll be talking about tomorrow, they've still only got 2 meg of flash. And we're at 1 meg usage now in ArduPilot. If we started adding Python in there, we're going to start running out of flash very soon, even on the next generation controllers. And RAM-wise, the F4s are going to be around for years to come, and we just don't have enough RAM to have ArduPilot and MicroPython. We could have MicroPython on the board, but we'd have to remove ArduPilot, which doesn't seem like a good trade-off. So Lua was basically the only one that would be current generation and next generation boards met our resource constraints.
So that would mean we'd have to use a second cube as the co-computer, is that what you're saying?
They have these things called single board computers for that.
The only other real option in this space would have been fourth. And so we could have done fourth, but we thought Lua is a lot easier for people to learn than fourth, unless they already know that type of language.
Yeah, if you ever redefine your minus constructor on yourself, which I've done, it gets interesting for operator. So it's designed to be embedded, which is basically the really long explanation George just gave us, but it fits very nicely for this. So we're using Lua 5.3. Out of all the other things, this is the most recent stable version of Lua, and importantly, it's the first version of Lua to have integers. So this actually lets us deal with integers directly, which is really nice for us when we deal with stuff like our location struct, which we have as an integer for precision reasons. So everything in Lua devolves down to a table. So you have your primitive data types, so ints, floats. You have user data objects. So those are actually C-managed memory that you then use the table functions to call into. But everything else is a table. Table is your only container. So you have stuff like Lisp where you have containers of lists and hash maps. C, you get vectors and arrays and everything else. Lua, everything works off of a table. So you can access a table like an array. So you can use indexes. And Lua counts from 1, so I apologize for that. Or by default, 1 is the first value in the table. But if you use in just a array-like manner, so 1, 2, 3, 4, 5, it optimizes it like it's an array. But you can also access it with string value keywords. So if you access it with those keywords, it acts as a map for you. So everything works off the one common data structure, which is really nice for passing around, and it limits how much you have to learn. And then you can pass around the user data objects, which are the more complicated ones. Interesting with the user data object, and this is how the actual integration works, is you can say this is the meta table. So when you call a function on something, it looks up a meta table for it, which is a normal table, and then goes and calls those functions. So user data objects are really just pointers into memory that have a meta table and a name associated with them. So if you got really complicated internally, you can actually define a class for yourself with your own meta table, and then inside your script, you've defined a new object that you get to pass around. So we ran a demo script yesterday. We're going to walk through it. Again, if this gets boring, just tell me, we'll jump over it. But we ran it on both this rover and Peter's rover. So the script was basically just picking a random location for us. And then when we got close, moved towards the target, it played a happy tone. When you moved away, it played a sadder tone. If you got within 5 meters, it played the battery fail-safe alarm, because picking tones is not my thing. But it gave you a point, and then picked a new location for you automatically. So I've broken the script into a couple slides because it doesn't fit on one slide nicely. So local acceptance distance equals 5.0. So I'm just defining something under the name acceptance distance for myself. You don't have to specify local. So if you didn't put local at the front, it'd be a global value that everything gets to access. If you specify local, it's everything from there down as far as any future closures go. In general, you'll see almost all Lua scripting defines everything as local because you get better performance out of it. And then we define a string value for the battery failsafe, making progress and away from it. And then I define 2 location structures. So these will always be available to us. So we allocate them that way. And then I set the top corner that we're going to pick points from. So this is hard-coded into the script. We should find a better way in the future, but it's a very silly demo. So we've hard-coded the lat long to be the top northwest edge of the Canberra runway. And then we set up some internal variables that we're going to use. So I just set the last distance we were away was, 1 times 10 to the 10th. So who cares? It's really far. And we've made no points yet. So then we actually define a function. So we're not calling this function yet. This is just the definition of a function. So a function find next point will copy into the target position the top left one we're going to start from. And we should define copy constructors in the future. So at the moment, I don't have a copy. So it's just taking the lat and copying it, and then the long copying it. When we look at these calls, we're using the semicolon, or the colon. And this is actually treating it like an object. So it's saying, on the object here, call this function. It then calls the offset function. And again, offset function is something that ArduPilot defined for us. So ArduPilot knows how to offset from a location in meters. And I hard-coded, 100 meters and 10 meters, and I didn't break them out to names because I was lazy and having silly problems in the field. Yep.
Could you short-circuit those first 2 lines by just saying target equals top left, doing the whole structure copy?
So that won't do a structure copy, that'll do a reference copy. So now you'll be pointing at the same user data as the target does, but or the top left. And when you update it with this offset, you'd be offsetting the top left one.
Syntax for copy?
I don't remember off the top of my head. I think you'd normally actually use table.copy as a table function, and then I don't remember how that interacts with user datas.
Right.
But I will look that up and get back to you with it.
Offer a copy method on every
Exactly.
structure. We could actually say target equals top left dot copy.
Well, really, what we should be providing is actually just a constructor for the location that lets you provide arguments to it, because then you would actually just throw away the old one. Who cares about the copy, and just allocate a new location based off the other one. And then GCS sendText. So the GCS function is something that I manually wrote the binding for. So it's slightly different, but that's fine. We can have manual bindings. Currently, it doesn't support var args. I need to actually do that in the future, but I didn't want to play with the VA functions in C. So I expect you to give me a single string. So I'm just using Lua string format to do all the string formatting for us. You do get normal string formatting out of the box, and that actually is Unicode technically. Now, you only have 50 characters to send a status text, so maybe don't use Unicode. So the current location, we allocate a new location. We then call the ahrs get position function on that. And this is currently sticking with the C API on get position. So internally in ArduPilot right now, when you ask for get position, you provide a location to fill out, and it returns true if it had a position to give you that was valid. So I've stuck with that now, and we're going to come back around to that concept later. But it just says, hey, if we have one, then go ahead and compute how far we are from it, so we can reset the distance function for ourselves. So we just reset our last distance. And then if you spot the bug, I always set the last distance back to 1e10, which is a silly idea and shouldn't be happening.
The return. If you don't do the return?
You don't need it. I just dropped it in because I was playing with something. So at one point I had this returning value, and then I just didn't delete the line.
Right. Okay.
This is the me taking this and putting this together during earlier talks, and we were hacking on it in the field. So the update function is what's actually doing real or interesting work for us. So again, just ask for a location structure, get the position, have white space errors on the next line. So we define a local to be skip update, which starts as false. Figure out the distance, print it out.
Left out the local keyword.
It'd be a global.
Be a global?
Yep.
Right, and it automatically creates it a global scope.
Yes.
Right.
And if you have a global, so if you have a global, say foo, which equals 1,
Yep.
and then in here you did local foo, this implicitly creates a local foo that's nil rather than referencing the global scope one.
Right.
So again, compute the distance, send the status text message. This is because we're using the notify buzzer, and if you get it too far away from yourself, you can't hear it, particularly when you put it inside a metal chassis. So if the distance is less than the acceptance distance, we play our tune, give ourselves a point, send, we got a point, yay, here's how many points we have total. Then call that find next point function we defined earlier. And then, we check if we've made progress or not made progress, play the appropriate tune. And then if we haven't done anything, we had an idle tune originally, but it was really confusing when you heard this idle tune, so we don't play tunes if you made no progress. And if you made no progress so that you can drive really slowly, we don't copy that to our last distance. And that then updates the last distance. And this last distance was declared outside the function, so that's what it's modifying. So if you refer to a variable foo, it'll check your local scope first, and then it checks the outside blocks, and it keeps working its way up till it finds one. If it doesn't find one, it's assumed to be global, and we write to it. And then the last key point is that update itself returns update. So it's actually referring to itself here. So it's going to say, return this function. And 5,000 says 5,000 milliseconds from now, try and have the scripting engine run this again.
5 seconds between runs.
Yep. Buzzers are really annoying things. You don't want to hear them all the time.
Yeah.
Just turn on that driver and you can demonstrate.
Well, it's got to get GPS fixed, and then it'll go poof.
It'll run into it.
Let me see if I copy that onto the next one.
So the find next point at the bottom there.
Yes.
Yeah.
So the last part is, if you can see this in a single file, what you'd actually be seeing is find next point isn't inside any of these functions. So when you load a script, we also immediately run it. And that's where that earlier copy and setup of our top left point was. So we can do interesting work on the one-off start run. So we start out by finding ourselves our next point. So this deals with our starting condition. And then when you start your script, you have to actually say, what we should schedule. So again, we actually just return from the top level of our script the update function.
Is there a sleep method in this?
There is not a sleep method, and I'm probably never going to give you one. So Lua itself supports sleep. I didn't bring that into the sandbox of functions you're allowed to play with. And if I gave you a sleep function, what that would actually do is you'd have a problem where you've now starved all your other tasks by accident. So if you want to sleep, you should just be returning yourself. You should return early and then reschedule yourself for a short period of time.
How can scripts store data which is accessible by other scripts? Like we have a blackboard of...
At the moment, we very explicitly disallowed that. In the future, we should add that. It'll probably turn into kind of a message passing thing that's managed through the top level.
Blackboard type thing where you can just, have a map, like a dictionary, a global dictionary that's accessible.
Yeah, and we might add that in the future. For now, I've very explicitly stayed away from it so that you have your isolation working correctly before we let you look at cross-dependencies. Peter?
There's something that we're going to have to give some consideration to is ArduPilot's API, which is there for these scripts. So, for example, several of the methods you're using there have been existed for weeks.
Weeks? That's ancient.
So there are several more methods that, or functions that should be methods to do with locations, which will be converted in the next few months. But anybody that's currently relying on those functions to exist is going to be sorely disappointed when their script breaks. So
These are internal APIs that now become sort of public APIs.
we're going to have to come to grips with this.
Yeah, and to an extent, we'll have to alias stuff. Depending on how we feel about it, we might introduce a internal script we always ship with the system that can translate APIs. At the moment, my stance is this isn't stable. We're not shipping to anybody yet, so we can break things freely, but we will have to deal with this in the future. That being said, I don't want scripting to accumulate the lock-in that we have with everything MAVLink based. I'd like to be able to keep that moving more freely. Now that might turn into saying, hey, this is compatibility versions where we publish an internal API number and change it periodically. But I haven't chased that any further than that at this point. So how to actually use this? You have to pass the enable scripting flag to WAF. If you're using SimVehicle, use the WAF arguments add-on to that. There is a README inside AP scripting that tells you how to pass that flag.
So this won't be enabled in all the pre-builts on the built ones?
No, it's currently not shipping to anybody.
It will be in the future, though.
Yeah.
Yeah.
Once we're happy or have more things and confident.
It'll be enabled by default on boards that have sufficient resources to support it. There are some boards that are too close on resources to enable it reasonably, but all of the boards that have like 2 mega flash will be enabled by default.
Yep.
Yep.
Any scripts inside /APM scripts, I didn't stick with the all capitalization because I wish we didn't have the all capitalization rule anyway. So we can have a future argument about that, but right now it's lowercase scripts. If you're running in CIDL, wherever your root folder is, where your eprom.bin is, just create a scripts folder there and drop any of your scripts in it that have .lua.
They have to be .lua? It will look for .lua?
.lua, yep.
Great, so it's not going to run the tilde files from
No, it won't run tilde file. In the future, we're going to look at actually caching the compiled code because compiling is actually what uses the most RAM, and that's what gets you into most trouble.
Yep. Subdirectories of scripts?
Not at the moment. I'm actually using that to basically, I have a skipped folder and I just throw stuff into that when I don't want to run it. In the future, what we might end up with is a auto start folder and a non-auto start folder. So auto start automatically goes and everything else you can just put. I want to look into letting scripts say, please load and run this other script now, but I haven't added that yet.
Can scripts include other scripts? Is there an include directive?
Lua has one. I don't support it. So we haven't done that at the moment. We could look into bringing that in the future, but I've very carefully not done that.
Libraries of functions, I think.
Yeah. And I can very easily see that we'll probably end up with some scripts that we deem fundamentally useful and ship inside the ROMFS file system for you that you can then invoke from that. And things that come to mind is I'd actually like to kill the camera library very badly because it's a dirty hack. So all that I really care about from the camera library is the external event feedback. And we keep wanting that elsewhere, so spin that out to a library. Camera library itself gets killed, and then you have a script library that just does all the same functions for you.
Is there a possibility to start any script, let's say, with the waypoint?
There's no conceivable reason you couldn't do that. We haven't done it yet. One of your trade-offs will be how long it takes to compile in the future. But yeah, you could have it. And you can definitely have a script already waiting for a waypoint. If we define new and interesting waypoints in the future, we could do that. But you're going to have a MAVLink problem at that point because your waypoint needs to be able to specify what script to run. And we don't have any strings in MAVLink. But you could have a registry potentially where a script says, hey, register me to be waypoint script with an ID of this. And then you plan that. But that's relying on you knowing everything about your stack.
Well, generally, you always want to be able to trigger things randomly from somewhere else.
Yeah.
So, what is that going to plan to be a MAVLink call or?
Right. So in the future, one of the things you really want is you want to be able to upload a new script to the SD card, and then say, run it now, and don't make me bother with this whole rebooting concept because I fixed something and I don't want to reboot. So that's on the to-do list, but it's not something I've chased too far yet. We will need real MAVLink messages of some form to do this, which will all be MAVLink 2, so you'll have to learn MAVLink 2. So if people are interested, we can do a demo of adding something new to the generator and put it into a script, but I don't want to drag people through stuff they don't care about. So is there interest in that? Or?
I'd like to see just the process because, once you feel comfortable with that, you go, all right.
Okay. So if we're good, and we can forgive bad typing live, because these are always dangerous things to do. So this is the ArduPilot folder. So if we edit AP scripting, and that is the branch that this is pushed to. So if you cloned my repo, you'd actually see this branch. So inside AP scripting, there's a generator folder. Inside the generator, we have a description folder that has the bindings. So this is the same thing we were looking at earlier. So let's go ahead and work with GPS velocity, because it always returns a vector 3f to us, and we'll just print it out or something. So we haven't done anything with GPS, so we need to include include apgps.h. This will be a singleton method velocity, which returns a vector 3f and takes no arguments. And I've cheated. I did look up the function signature before we started this.
Right.
So write the file out, and then if we cd off into the scripting folder and generator, we can run the make file. So make run. And I can't spell. So it prints out everything as it came through. And I think the projector is slightly off screen. But all we did here is there's a make file. And make run will automatically compile and run the input for you. Hey, look at that. So if we clear screen, that was just make run. Nice and exciting. So that will automatically generate the file for us in the parent directory. And that's just described in the make file how to do that. So then we can go ahead and let's go up and edit our script first, because I'm going to have trouble getting too many windows. So what do we have in scripts? So this is the same script we were just looking at with other bugs, but who cares? So inside update, let's go ahead and say foo equals GPS velocity. So singletons automatically show up in the globals for you. So anything that you declare as a singleton will automatically be a global, and you can just call it.
But foo is global there.
Yes.
Right. Okay.
We could make it local, but
yeah.
I was being lazy. Fewer things to type. And then let's just print it out rather than do anything too interesting.
Could we have like a debug function, so you just go debug and then something, and it assumes it takes a string and
so I've been
to do quite verbose?
I've been debating adding a binding that says if you define a field, so like vector 3fs all have fields, right? We know how to access the x, y, z field.
Yeah.
I've been debating adding a toString function, because Lua supports that says implicitly everything that's the user data has toString, and just prints everything out for you.
Yeah.
I've held off because it's a useful debug function. I wasn't sure if it was worth the flash space at runtime, because usually you only do this when debugging.
I'm more thinking of the GCS send text in the string.format. I mean, could that be like debug, open parentheses?
Well, if you had toString, you could just literally do gcs.sendText foo. If I provided the toString function, that would just print out everything nicely.
You're saying debug.
DEBUG break. In other words, getting rid of the GCS.10 text.
Single defined.
Yeah. All right. No, okay, keep going.
I would quibble that that's a very small change either way, and more functions for just hiding the same functionality. But we can come back to that. And then we just need our arguments. So foo.
So no commas?
Commas are optional. You can absolutely add them, and it just goes right over them, no problem.
Okay.
So if we write that out, we can WAF configure and enable scripting. And you will see if you provide the enable scripting flag, scripting is enabled. There's also runtime checks that are extra paranoid. Those are always enabled for you inside of CIDL. They're not enabled by default on real hardware. I have never seen them trigger, but they are just internal sanity checks. So if we compile everything, and I just have this aliased off to that command. So that's waiting for connection. So let's pull up a mav proxy window, and I did prep 2 terminals. Kind of readable. That's Python 3 error. It's not my Python 3 error.
Oh, okay, didn't know about that.
Peter did. Peter didn't want to fix it.
He's still got
And then right here, I stuffed up.
Syntax error. Okay, just give you a line number though.
You should actually get a line error. The problem is syntax errors. Lua compiler and syntax errors are not always the cleanest things. So, live demos and errors sounds perfect.
Let's see if we can spot the error. Foo equals GPS velocity. Yeah.
Where?
At the end of send text.
Yep, see?
One more.
Things are always dangerous to do without just having everything stashed, but nope. See? So,
What was that you fixed?
I don't know. I basically just commented at the line to see which one was the problem. So, and here we can.
That seemed to start.
So script's running. That's cool. So it's definitely in that second line.
Syntax format.
See if I just totally lied to you about parens. Because maybe I lied to you. I've been playing with too many scripting things recently. I'm a dirty liar.
You need the commas.
Yes.
Hey, good.
So if we speed up. Which I can't spell and things are printing out, but. It's also not my error.
Yeah.
So it's taking off its quad plane, but you can see that your velocity actually is changing now based on CIDL. So it is actually reading data rather than just printing out happy zeros on the ground.
Yep.
And this is running 10 times faster in real time. So even though the script is scheduled for 5 seconds, you're seeing it print out much quicker.
Fantastic.
So if you set the sim or SCR debug level parameter to something greater than 2, you get these extra things that print out, which tells you the name of the script you're running, how long it took to execute the script in microseconds, and then the amount of scripting memory that consumed compared to start to finish. It doesn't say anything about if you did a garbage collect in the middle and then allocate everything back up. It doesn't tell you. It's just the delta between when you started and when you finished.
Yep.
So knowing how long it took is important, but to a user, it'd be nice to know how much, like available, free microseconds there are.
This is called debug level. It's a good question. I don't know how to ask the how for that yet, but that would be very nice.
What do you want to ask to help?
Basically, free slack time. How much time is unused
How much
and how much
idle time
yeah.
there is on the CPU?
Yeah.
Okay, yes, we can certainly have that. Yep.
Yeah, because it says 30 microseconds or whatever. It would be nice to say 30 out of 5,000 or something.
Are you putting the scheduler to
Not at the moment. So I'm my own thread as far as the RTOS is concerned. I'm not doing anything with AP scheduler. I'm just a direct thread.
No, you're running over the scheduler. Oh, you're running thread, right?
Yeah.
Could you have each script in its own thread?
You can. You get into the realm of destroying your RAM now, because each script needs its own Lua state object, and then everybody needs the memory to compile.
What's the cost of that in RAM, roughly?
12K startup cost, I think, basically.
Right.
So it's not insignificant.
But it would lay you to sleep.
Yes.
Right. Yeah.
We might be able to bring back the coroutines library to let you do sleeping as well, but haven't chased that yet because it starts to interact weirdly with the scheduler.
Yep.
Well, could you have a thread with variable size stacks?
So the problem you run into there is that the
Stack.
Chibios doesn't really, you can do that to an extent, but you have to be able to fracture across it. So you might have free memory, but you can't use it all correctly. But yeah, you can allocate multiple sections together, and then inside Lua alloc, which is the wrapper for alloc, you try to allocate the first one. If that fails, you go to the second one, and then you'd return failure. So that would work, but we haven't chased that. So open questions, and I really do want actual feedback on what people think is appropriate or not. So Lua supports multiple return arguments. So you can actually return 3 things from a function, and it'll destructure them nicely for you. So with get position right now, this is the very straight version of the ArduPilot C API. The downside is it's the C API, and you have to deal with weird oddities where you pre-declare your storage location, and then it fills it out for you, and then returns it. So there are 2 other options that come to mind. The first one is get position. In the generator, we could tag that, hey, the location is going to be reference variable, so create one yourself, fill it out, and then return it to me. So you could actually return a Boolean as your first argument if it was true or not, and position as the second one. You'd actually only return the second one if we had a valid position. The other option, the one I'm kind of partial to, is foo equals ahars get position. And what you say is you basically do this nillable punning thing. So if position wasn't available, we return nil. And inside Lua, you go if nil, if you didn't have value, then who cares? Or you return just the valid reference. So this would only either return false or nil. I haven't really decided which one yet. Or a valid location struct to you. This makes cleaner scripts. It's more of a stretch for the C people in the room, but it is much more common for a user to deal with that. So I'm kind of curious, do people have a strong preference for any of these 3? Or
For the last one. Anyone else?
Anything that annoys the CUs.
gotta find the ones for the Python
it's
users.
It's a little more Python-esque, actually. You're checking for none, basically.
Yeah, it's much more closure, which is actually where I went.
But what about showing there, though, is you still need to do the if foo is null check after it, right?
Yeah.
Yes, but what you can also do is potentially, if all you really cared about is do I have one, you can go directly into the function. And yeah, you still need the if as the next line potentially.
Is there a Lua thing where the if and the fetching of the value is all on one line?
I believe there is, but don't quote me on that. It's been a while since I've poked at that one.
So that's part of the answer, right? Yeah, part of the answer is, well, what does it look like?
Yeah.
In this case?
I think you can collapse into one line, but I don't know that for sure, so I don't want to promise that. But yeah, if you can, that would be much nicer, because then your if, your destructure variable, assignment.
Sorry, just on that previous slide,
Yep.
it depends on the guarantees about what value of foo is after the get position call, things like that. So foo is like our typical cache values, the cache current location in 3 different places sort of thing. Then the first one might actually be more useful than
Well, the last call is promising to assign something to foo. Ahars get position has to return a value. So it'll either be nil or your new position. So it'll never actually be stale. Now, what this does cost you is that because you've assigned a new value to foo, if you were trying to reuse the storage location you'd already allocated, you weren't getting that. So in this first one, location, this foo is the same object. We never create a new one when we call ahrs get position. Either of these later two ones, we're allocating a new foo every time you call the function.
Generally speaking, the less you deviate from the programming language, the less you have to document, and that is usually a good idea.
Yeah.
I agree. I think, as like ArduPilot developers, we probably want to make it look like ArduPilot, but actually...
I really don't.
Well, I would want to make it look like ArduPilot, but obviously it makes sense to me. I'm sure the Lua scripting guys are most comfortable.
The ability to figure out where the behavior comes from, unless you're going to write lots of docs.
Yep.
The coroutine stuff is something that, because you'd really want to say, stop the script here until we have a position, or pause in this logic until we have reached that distance.
Yes and no. Usually you turn into the fact that if you get to that, anything you cached before that is stale in my experience. So usually I need like 3 things to do. I need my attitude and I need my position. I got my attitude, sure, but I didn't have my position. So you might actually need to requeue everything anyway.
Right.
But coroutines are kind of a different debate in the future, if we can make that work well or not.
The other thing is to have const references, so you could actually have a const reference into the attitude, so it updates automatically.
No.
Not writing.
Yeah. I really do want to keep that separation if at all possible.
But not being able to write to them, but being able to have a read const reference would be
Your
really useful.
problem with that is you have to actually, that can't be the same user data object anymore. That has to be an entirely new type to be limited scope. So you've doubled the flash space because now I need 2 identical functions.
Right.
But because if I reuse my existing one and I pass it some other function, that function doesn't know it's not allowed to write to it. So you'd have to actually duplicate your code paths. So I really want to avoid that if at all possible. Even if it means, yes, you have 2 objects, that's okay.
You also have obviously have atomicity issues there.
We have that now. I mean, if you pull attitude and altitude and roll and pitch, I mean, each of those you can be rescheduled in between. There could be 50 loops of the AAJ.
Coming to that one.
Yeah.
Buzz?
It's probably more of a Lua 101 question, but does Lua have like exception handling, like try except kind of?
Yeah. It's called a P call, which is weird, but yeah, it's a protected call to a function. So yeah, you can't actually, if you call something and it throws an exception back at you, like if you called ahrs get position with nil, it actually throws an exception. If your Lua script catches it, that's fine. And I don't see anything if you catch it.
So that's very sort of Pythonistic that way.
Yeah. And if you don't catch it, then I catch it at the outer level and I print out your stack trace and error. Although it's not much of a stack trace.
Functions that might be handled differently like this, would it be beneficial to name, within ArduPilot, make some aliases with like Lua in the function name that just call something like get position, but it's...
You have to then actually modify your C code every time. So if we can make the generator handle these naturally for us, it's a lot easier to add new support. And if we're going to have to put the code into both the generator anyway and make a new C function, I think we should really just try and handle that all on the generator side rather than split the effort and make part of it a manual effort and part of it automatic.
Probably might find having a top-level generic, auto exec Lua that pulls in all the globals that are commonly used might be also the way to start. Something like that.
Yes and no. You actually run into the fact that if you pull in all the globals that are commonly used and you don't use one, you've paid a memory cost for it. Now you could reassign it back to nil and let it be garbage collect, but now you have scripting, which is taking up RAM because you have to load the machine code instructions for it to do that. So really, I want to let you load the things that you need in. So we would provide a sandbox at the top level, but really want to keep that minimal. And then just to speed through, because I think we're going a little slow. We talked about this one earlier, so everybody seemed fine with get singletons always returning pointers. So locking problems, and this at the moment there is no locking inside AP scripting. So if ahrs updates position while you're in the middle of copying it, well, that's just too sad, and that's not a very good solution in the future. My original proposal for this had a global lock, which would have been very easy for scripting. And I got poo-pooed that we should do fine-grained locking everywhere, but it has me really frustrated. So the problem with fine-grained locking is that everybody now needs to do the locking. It's not just scripting. So if I do a global lock, scripting has to release it to the scheduler table as soon as it wants it, and that's not too hard to do. If we do fine-grained locking, every time I add a new lock to something, like ahrs has no locks right now. So every time I add a lock to it, I have to go actually add that to the vehicle code as well to limit where those come into. And that's really going to hold up binding in descriptions, or adding more and more support every time you have to go deal with those complexities.
We don't need locks in a read path that is in the same thread that updates the data. And so that actually lessens the number of locking we need enormously. It's only cross-thread that we care about.
It's less, but it's not. When I went through it, it was less than there were more locations than I thought would need it originally, particularly the.
It's the MAVLink and logging.
It's the MAVLink, the logging, and actually I found some sensor drivers because they're on their own buses that had problems with this.
Yep.
So starting to introduce that got to be worrisome, but I don't really know the final answer for that. And my other concern with the fine-grained locking is locking dependency order. Now you can promise inside the scripting side that you say scripting will only grab one lock at a time and release it as soon as anybody needs it, which fixes a lot of locking problems.
Right.
But as we introduce more and more fine-grained locking, if I introduce fine-grained locking for AHARs and GPS libraries, I have much more of a race condition now that I got the AHARs and the GPS wrong when I went and added that.
Yep. The other way to do it is to do it part of the singleton. When you're like, give me singleton with lock, which then gets released when your local copy of the singleton goes out of scope.
Yeah, but I get way more concerned then about dependency problems, because if I call AHARs give me this, AHARs might need the GPS lock,
Yep.
which somebody else had at the same time, and that thing might have actually then needed the AHARs back inside the same scope.
Recursive semaphores.
Right, recursive semaphores work. Don't you still have the problem when you get ABC, and then you do CBA?
Yeah.
Don't you still have a problem? Or ABC, ACB, whatever it is. That one has a locking problem, regardless.
Yeah, more thought needed.
Yep, so that's one of the open areas. Vehicle-specific bindings. Everything I've talked about so far has all been AC libraries, AP libraries. So we'll need to add a vehicle interface at some point. So everything right now is you can read state and you can mess with your external sensors, but you can't tell the vehicle to, drive over here, which you probably want to be able to do in the future.
Yep.
But for now, we're just going to kind of leave that as an open question. And then one of the other questions, which we might be able to answer quickly, is right now this is the bottommost priority. Even logging has higher priority. Do we think this should at least be the same priority as logging? It's one of the few times Peter's ever gotten to be higher priority than something on the system, so maybe we should let him keep it. But I don't have a strong opinion at this point.
We might actually end up with a parameter for scripting priority.
We'll have to very carefully range check that one.
Or have a priority in a script, per script, because there's no reason it couldn't change priority for different scripts, and you actually have a priority declaration in the script, which then affects just that script. More importantly.
No, you can't. That becomes a problem with scheduling multiple scripts, because if my low priority script is the next thing in the task queue, I have to keep the high priority. Unless we say, hey, we just run at the highest priority script request.
Maybe.
But you have to always honor your highest request level, otherwise the task switching doesn't go right.
Well, unless you're sleeping.
Well, no, because then nobody else gets to run. So things that I'm working on and upcoming, more API access and the rest of the Lua libraries that are currently disabled. Documentation and test cases, that's probably the next major thing so people can actually enjoy and use this. I'm hoping a lot of documentation becomes the test case code as well. Adding support for MAVFTP, because you can't get your scripts onto it easily. So that should make some people happy for various reasons. Add a REPL. This is one I'm actually most excited about. So REPL stands for read, eval, print, loop, if you're not familiar with that. So that's the thing you normally get with Python where you can just type into it. There's actually a Lua one. Yep.
You've got to be very careful with that. I mean, remote pilot license in Australia as well. So.
I'm going to give you all your remote pilot licenses. No problem.
Download a new version.
Just something to clarify.
If you get some features in there called CASA and
That's a dumb function. Yeah.
But the REPL is exciting. REPL will let you do everything you do in your script, but you could do it from your console on your computer. So that replaces kind of what you had with the NSH console before. But it also will let you just say, hey, I'm really curious what the state of AHARS is right now without going to, your data flash log. So giving you an ability to inspect the vehicle in real time is actually pretty exciting. And if we give you access to stuff like UART ports, you could actually be manipulating your sensor drivers directly and go, that didn't work, and play with it and prototype it in the console. So that's the one I'm most interested in. And then finally, add MAVLink handling. I kind of regret signing up for that side. But the idea is to let scripts actually say, hey, I care about handling these MAVLink messages. So internally, you could say, I know ArduPilot doesn't care about camera mount aim 30 degrees up and left message that got added, but my script really does care. So a script could say, hey, I can come handle this message that ArduPilot didn't. And similarly, the script would be nice to let it publish stuff out of the system and say, hey, I have these cool status bits for you that you didn't care about because I've added this capability.
Because you've got your game, just say, hey, what's the score of the game at the moment? How's the...
Yeah, you can do stuff better than just print status text and hope you understand the status text on the other side.
If you did handling, could you override existing handling? So like the script could handle first? Okay.
Probably later. So the problem you run into is, again, the priority system. So if you said scripting has to wake up and handle it, the script has to finish the current script before that handler can be invoked. So your MAVLink thread is now stuck on waiting for your script thread to get time, which could be, 2 years from now because you've vastly overloaded your scheduler loop rates. So what will actually end up having to happen is you try and handle it on ArduPilot. If it doesn't handle on ArduPilot, you stick it into a queue of messages for MAVLink to try and handle. And if you get too many messages, you throw out your oldest one. And then the script can go, can I work with this or not? But it's still very loose thoughts at this stage. And I seem to be out of slides, so there we go.
Any final questions?
So on the MAVLink handling, one last thing is, so was the intent to handle messages that are currently defined but unhandled?
It's actually to let you handle any arbitrary MAVLink packet. So you could actually extend that to say, hey, I know ArduPilot hasn't been recompiled to understand this, but I understand this packet. So the plan was to actually add a unpacker, basically for arbitrary bytes. But the handling of that will get a little bit interesting. But part of the goal of scripting, right, is that you don't want to have to recompile the autopilot every time you need changes. So that means if I want to do something interesting with MAVLink, I don't want to have to update PyMavLink to update the ArduPilot, to update the MAVLink definitions into ArduPilot before it gets to me in the script. So the target is to do arbitrary messages you've never seen before.
And that sort of unpacking thing, would that be built into every, redundantly on each script? Or would it be one script that just manages that?
I haven't chased that yet. I suspect that because of the complexity of doing the unpacking well, I might provide that to you as a utility script that you only load if you're going to do that, because you probably don't want to spend the overhead otherwise.
But won't we have to do that? We're talking about forwarding and caching all the scripts in the MAVLink library for you to be able to get it, because otherwise it's going to be eaten by MAVLink first.
Yeah, MAVLink is one where you're probably only going to opt into it. And I'm really hoping to avoid saying, you have to make the generator, right, to do the packing. I'm hoping to avoid saying you have to run this special code generator to dump the Lua code for you to use. I'm hoping to avoid that step.
Can we do something like when certain MAVLink message happens for certain, it basically calls this script, callback to the script inside the ArduPilot?
Ideally.
That command would be the standard one, like MAV command.
Sorry, I didn't quite follow the end of that.
So let's say if there is a MAVLink command message that is coming in, it basically has additional layer where it calls a script,
yeah, ideally.
Script, and the script starts with that MAVLink command messages inside it.
Yeah.
And there we can do the handling of the command type.
Yeah, you don't want to. Again, you have to queue it off into future work for the script task. You can't handle it immediately, but yeah, you can do that.
One way of doing the MAVLink is PyMavLink, the generator, already has the option of generating an introspection table that's used by our test suite, and it gives you this great big table that could be in Flash that tells you the names of all the fields and the locations of the fields and the structure, the size of the fields, the message, the CRCs, all of those.
And the problem is you're going to have to cut that table down massively to fit in RAM. So
No, but it'd be in Flash. It's constant.
Right, so I want to avoid the Flash side because it's still a large table, and I want to avoid Flash because I want to be able to do arbitrary messages I never knew about before.
I'm not sure if I missed this before, but talk about inter-script communications.
To be done in the future.